Hello, everyone. Today we're going to be doing a full review of AP CSP. So AP CSP is split into 5 big ideas: creative development, data, algorithms and programming, computer systems and networks, and impacts of computing. So now we're going to go over to the first big idea, creative development. Collaboration. So first, we're going to go over a quick definition of what a computing innovation is. A computing innovation must include a program as a major part of its function. It could be physical, like a self-driving car, or it could be software, the program. Collaboration, I mean, you all probably know what collaboration means, right? But like just having many people work together to do something, create a task. So in programming, collaboration provides diverse viewpoints and talent in the design. This will help reduce bias because of all the diverse viewpoints, different people gathering around to create something, so the bias will be reduced. Furthermore, now with the world becoming more digital, online tools allow ease in including diverse people's opinions. For example, holding Zoom calls with people from around the world to get ideas for your innovation. Now I'm going to go over what programs are. So programs refer to just collections of code statements put together for a task. Programs generally take an input and will have an output, which is the purpose of the program. Inputs can be audio, text, or visual, or many more. Inputs will come from users or other programs. For example, in Amazon Echo, the input is my voice, and then it'll respond from that. So the program's output will be based on its inputs. Programs can go through development processes where they will be adjusted, reviewed, and given feedback. Investigation, like user testing, reviews, and observations, allows programmers to identify the program constraints. This is all pretty much just basic knowledge. Just know what programs are and the fact that programs, to develop a program, they need to be adjusted along the way. And that there are many ways to check whether a program is doing what it's doing, such as user testing, where users will test it and give feedback, reviews of users, and just looking at observations from the program itself. Program errors. So here are some errors that can cause your program to not behave as you want it to. So logic errors are simply mistakes in the algorithm that'll cause it to behave incorrectly. So it'll output a wrong answer because of a logic error. Maybe you added 10 instead of 5. Syntax errors are mistakes in the programming language. So programming languages all have like a set way that you need to write the code. If you don't follow that, you get a syntax error. Runtime errors will occur in the execution of a program. For example, if you're accessing an element in an array which is out of bounds. So it's not going to be a syntax error. It's just that when you run it, the program realizes, oh wait, there's an error here, and it can't run. Overflow errors will occur when a compiler tries to handle a number outside its defined range of values. Overflow means like going out of. You could use that to remember an overflow error. And in general, to solve errors, debugging and looking at test cases and just running the program or visualizing can help reduce errors and find the problem in the code. That was it for the first big idea. Now we're going to go to the second one, data. So how do computers store data? Computers store data in something called bits, which are base 2 numbers. all the numbers are represented with ones and zeros. For example, let's look at 100 here. 100 in base 2 is 8. And a simple way to convert a decimal number, which we use is base 10, to a number in a different base, such as base 2, is just just repeat this, find the highest number or the highest power the base can be raised to, and then subtract that from the number and continue on until you get 0. For example, 2. Let's look at 100 in base 2. 2 to the power of 3 is 8. 2 to the power of, so it's 1. 1 times 8 is 8. That's why the rest of these bits are 0, because you already reached 8. Also, know that a byte is defined as 8 bits. However, in general, we, the programmer, we can represent data just through lists, variables, or constants. A computer is the one who converts that to bits, so then they can understand what we're doing. And many bits grouped together can be abstractions, such as colors, for example, RGB. Furthermore, you all should understand that context matters a lot in programming. The same sequence of bits can mean different things in different contexts. In one context, it could be a color. In another, it could be maybe the height that someone will jump in a video game. Analog data refers to data which changes smoothly over time, such as pitch and a sprinter's position. Obviously, over time, the data will be changing bit by bit at each point in time. Digital data can be used to represent analog data. You can represent the analog data digitally, and this results in a abstraction. Abstraction, as it sounds like, is simply taking a complex topic and making it simpler. Well, not exactly, actually. It's more like for some topic, taking it and abstracting it so it's easier to understand for people. Sampling techniques can measure analog data at different intervals called samples, and then use all those intervals to find or to model the analog data. And all the programming languages, they have a fixed number of bits integers can be represented by. So if it needs more bits, in Java at least, for example, you'll use a long. But if you still use an int, then it'll be converted to like a much smaller number. And you can consider that an overflow error or a round-off error. A round-off error will occur when it's too precise. So like maybe 0.000000, like a lot of zeros and a 1. So that's too precise for the programming language to keep. Overflow error will occur when it's too many bits to store. And yeah, as I mentioned in the previous slide here, round-off errors are due to limited precision. Overflow errors are resulting in a value being too large to store. So you all should know how to convert between bases. Try converting 10 from base 10 to base 2. And the answer should be this number here in base 2. So basically what you do is you find the highest power of 2, that is less than 10, 2 to the power of 3. 0, 1, 2, 3. That's the first one at the top. Then you find the next one. 10 minus 8, 2 to the power of 3 is 2. 2 to the power of 1 is 2. 0, 1. That's the one here. 1 minus, 2 minus 2 to the power of 1 is 0. So fill the rest with zeros. Data compression. Data compression refers to reducing the number of bits of transmitted or stored data. It's pretty obvious why this can be helpful, as you don't want a file to be too large, as it might be hard on your computer. So there are two compression algorithms that the exam wants you to know, and each has its own advantages and disadvantages. Lossless compression reduces the bits while guaranteeing a complete restoration to the original size. Lossy compression reduces the bits in data while only allowing an approximate restoration. Therefore, depending on what you want, use either of them. So lossy data compression, you only get an approximate restoration. So that's why you reduce the bits more than lossless compression. You lose something. That's why it's lossy. You lose something, so you won't be able to restore it, but you compress it more. So the data size is smaller. So if your priority is minimizing the data size without full care about how it'll look, about how you want it to be restored, then use lossy compression. Lossless compression allows you to still reconstruct the original data back to its original shape and form. So therefore, lossless means you don't lose anything. You won't lose anything from the data, so you'll be able to fully restore it if you want. So use lossless compression when it's vital that you want the original perfect replica as before. So data provides opportunities to make trends and identify connections. Identify trends and make connections. You can see correlations and patterns and so on from data. Digital data can show correlations, but then again, correlations do not always mean causation. To establish causation, you need a well-defined experiment. Metadata refers to data about the data. For example, let's say I take an image. Metadata could be the time, location, and where it was taken. If I take a picture of the sky, metadata could be the time, maybe 12 p.m., and the location, 500 feet above ground. Therefore, changes to metadata will not affect the data. For example, my image of the sky, changing the metadata, like let's say I just change, I took it on the ground. It will not affect the data, as the data is just the image of the sky, even if I say that I took the image on the ground, even though I took it in the sky. Metadata allows you to get more information about the data, which allows for structure and organization. So data needs to be cleansed. This is very vital, as you don't want incomplete data. Incomplete data will be hard to analyze. That's why data sources sometimes need to be combined for further purposes. And data collection may not always be uniform. Cleaning data will make the data uniform without changing the meaning. For example, let's say I have the data set of places where I went, or places where I went in the year. Let's say I have all these different states, Alabama, Alaska, California, and I put California in 3 different ways: California, and Cali. They all refer to California, but to make the data uniform, I'll change them all to CA, because they all refer to the same place, and that'll be easier for programs to identify. Bias can be reduced through thoughtful data collection. If you're smart about where you're choosing the data, you get it from different places, bias will be reduced. But if you get data from all the same place, bias will be hard to reduce. Larger data sets do have more information to be extracted, but there is a trade-off. With larger data sets, it'll take more time to get all of the data. And it might require more complex computing systems, such as parallel computing, which we will go over later, and you might need to scale it more. So programs can be used to process data for information. Tables and diagrams can communicate insight gained from data. Datasets can be filtered and transformed for the programmer's benefits, And data sets can also be merged to gain insight on patterns. Yeah, so programs generally just use data. You can represent data in many ways, like tables and diagrams. And sometimes you will need to change the data set and merge different data sets to get a better view on patterns. Now we're going to go over algorithms and programming. Variables. Variables just think of it as something that holds a value, and you can refer to that later in the program. You can use different names to name a variable, and it's good to be creative, so you also get the variable's purpose. Sometimes programming languages such as Java make you define a variable type, but sometimes not. The compiler might just understand it, like in Python. For example, let's say I have a variable that represents the height of the clouds, or the height the clouds are above the ground. It would be better for me to name the variable height, right? Height of clouds versus just h, because height of clouds is more specific. Assignment expression refers to assigning a value to a variable, and every time the assignment operation is done, the variable's value is changed. For example, here I'm assigning the value 5 to the variable a. But if I did that, if I did it again, let's say a equals 10, then the value of a is 10, and the value of 5 is not there in a anymore. Lists can be used to represent many variables together. List, as it seems, is just like a list of a type of variable. And indexes are used to reference specific values in the list. On the AP exam, well, usually in programming, the first index is 0, but on the AP exam, we assume the first index is 1 for this class. The value at index 1 of this list here is 1, index 2 is 3, index 3 is 4, index 4 is 11, and index 5 is 15. The length of the list is 5, as there are 5 numbers in the list. Strings, you can think of strings as sort of a list of characters or a word. For example, this. You can also concatenate strings. Concatenate essentially means just combining. So this string plus this string would be this string. The second string starts at the end of the first one. Lists also help create abstractions. You can use lists to abstract more complex topics. So there are several math expressions the AP exam wants you to know. Addition makes sense. Subtraction, division, multiplication. Addition, you add stuff. Subtraction, you subtract. Division, divide. Multiplication, multiply. Mod might be something new for you guys. It essentially gives a remainder. For example, 10 mod 3 is 1. The remainder of 10 when divided by 3 is 1. And in general, normal PEMDAS operations, order of operations will be used. What you learned in earlier, in probably in middle school. And here are some more things, more expressions, Boolean expressions. So and means both the conditions have to be true for it to work, or means only one of them has to be true, and not means neither of them can be true. So if statements help control the sequential control of a program. If a condition is true in an if statement, the program will go to the block, but if not, it'll just go outside the block. Unless there's an else statement, if there is an else statement, essentially if the if statement is not true, then it goes to the else statement. And conditionals can be nested. You can have an if statement inside an if statement. So if the first condition is true, it'll go inside the first if statement. If the second condition is true, it'll go inside the second if statement, which is inside the first if statement. So loops make it easy for programmers to do the same task many times. For example, let's say you want to print 1 1,000 times. Of course, you can just say print 1, print 1, print 1 1,000 times, but that'll take a long time. Instead, what you can do, you can create a loop that'll repeat the task inside the loop a certain number of times. So there are two types of loops. Repeat n times, you give the value right away, or you repeat until x, where x is a conditional. Repeat until x is true. While loops are repeat until x is true. So while blank condition is true, or I mean, my bad, repeat until x is false. So while condition x is true, keep running. But when condition x is not true, then you stop. Unfortunately, while loops can run infinitely if the condition is never stopped, and it might not even be run if the condition is not true in the first place. And the different type of loop is called a for loop, where you repeat it n times and it's given to you straight away. That one's straightforward. So now I'm going to go over a list again. List is a group of a certain variable type and has many values in it. And you can access the element at the index I of a list by doing this on the AP exam. In programming languages, it might be a bit different, but on the AP exam, if there's a list called a list, and you want to access the element at index I, where the first index is 1 and so on, and it goes up by that, this is what you do. And furthermore, you can adjust the value at the index I by just using the assignment operator. A list at I equals X. X will be the new value for that list at that position. You can also insert a value to a certain index, which will be shown as insert on the AP exam. Essentially, you just put the value that you're inserting right at that index. Append on the AP exam for list means you add a value at the end of it. And you can also remove an element from a list by remove. You'll remove the element at the index that they give. Furthermore, you can iterate through each element in a list by doing this for loop. For each item in a list, and then do whatever you want with it. You can print it, add one to it, and so on. And linear searches can be used to look for a value in the list. A linear search is just when you start from the start and you keep going until you find the value you're looking for. Now I'm going to go over binary search quickly. You don't need to have a really deep understanding, but just know that you can only use it on sorted lists. It's more efficient than normal linear search. Essentially, how it works is if the list is sorted, right? And you're looking for a value, let's say it's a list of numbers, you first start at the middle index. If the value at the middle index is too big, then you basically remove the top half because you know it's not going to be there since it's in sorted order. And you keep doing that until you get the value you're looking for, or if you realize the value is not there. Procedures. So procedures in normal programming languages might be called methods or functions, but procedures are essentially just a named group of programming instructions which have a purpose. They may have input parameters, and most of the time they'll have a return value, or they might not. So parameters refer to the input variables, and the arguments are the things that specify the values of the parameters. Different parameters might lead to different outputs depending on what's called in the procedure. So whenever you call a procedure, then the program goes to the procedure's statements inside the procedure with the input parameters you gave. And procedures can sometimes return a value, or it can display, which is essentially print a value to the terminal. Procedures can also be an example of abstraction. For example, let's say you have this huge complex procedure. You might not know how it works, but let's say it's a common procedure used online, but you know what it does. Then you can just use that procedure, call it, and you don't have to code it. So you abstract that entire process in that one procedure, even if you do not know what it does. And it also helps code readability. For example, let's say you have a procedure that counts the number of trees in an area. If you have it if you don't, you should probably just group it. Have all the statements in one procedure. Like for example, search the area, look for leaves, look for the trunk, and then determine whether it's one tree or not, and then remove that tree from the area. Have that all in one procedure, one block. So then if you want to use it on a different area, you can call it again. And subdivision essentially refers to separating subprograms, having different programs for different purposes, and that overall helps the program work better. And that's also refers to as modularity. Libraries. So software libraries have built-in procedures which can be used in new programs. The use of libraries simplifies creating complex programs, as it's already built in. APIs refers to application program interfaces, and they are specification on how to use procedures in a library and how they behave and how to use them. So every programming language will have an API documentation, which lists how to use different libraries, and it's really useful. Simulations. Simulations are just abstractions of complex processes. They use a varying set of values to represent a varying state of a phenomena. For example, let's say you want to simulate the weather. Of course, waiting might take a long time, just waiting for the actual weather. That's why simulations are useful. You can simulate it much faster and realize what's going to happen. Simulations can sometimes be biased, but it's supposed to be used to simulate real-world events, as it would be much cheaper than just waiting for the events to happen. Bias can unfortunately occur in simulations. If, for example, the data you use is skewed in one way, the simulation will only predict one thing happening instead of the different outcomes if it is biased. You can create a random number in a program by doing this, random a comma b, which will generate a random integer between a and b. This is how it will be shown on the AP exam. Sometimes generating random numbers are useful to simulate variability that will really exist in the real world. Algorithmic efficiency. So decision problems refer to problems that have a yes or no answer. Optimization problems refer to finding the best solution possible. Efficiency is measured as computational resources used by an algorithm. It can be sometimes expressed as the size of an input. Usually, let's say it's the input size n. Sometimes, let's say the procedure will run n statements, then or it'll run the number of statements in the program, then the complexity can be, and efficiency can be O of n. And it can also be informally measured, as I stated, by the number of times a group of statements occurs. So on the AP exam, algorithms with the polynomial efficiency or slower are said to run in reasonable time. I mean, polynomial efficiency or faster are said to run in reasonable time. For example, a constant, a linear, or square, or cube, etc. That's said to run in reasonable time, but exponential or factorial algorithms can run in an unreasonable amount of times. You can probably test this out yourself, but for exponential and factorials, as n becomes larger, the numbers expand extremely fast. But for squares, for example, it won't expand as fast as these two when n gets really big. Heuristic algorithms refer to finding a solution which may not be all the time accurate, but should use a shortcut and will run faster. Basically, if you're not trying to find an exact answer, you can use a heuristic algorithm. And when optimal techniques will take way too long to use, you can try using a heuristic. So decidable problems refer to problems that can be solved by an algorithm for all the correct outputs and can be produced for any input. Any input given, the program will produce an answer. But undecidable problems, it cannot be solved by an algorithm for all the possible inputs possible. That's the difference between the two. So use all of these skills that I've stated. These skills can be used to create algorithms. Algorithms can be written in different ways for the same task. You should know that. And algorithms include many examples. Basic ones can be just finding the minimum or maximum of two numbers, determining if an integer is divisible by another, or finding the sum of a list. Or it can be extremely complex, such as determining whether a sample image is an example of skin cancer or not. Now we're going to go over to the next big idea: computer systems and networks. The internet. So computing devices are the physical artifacts that can run a program. Computers, tablets, and routers, and so on. These allow you to run programs, and they can usually connect to the internet. Computer networks refer to groups of connected devices which are capable of sending and receiving data to each other in that group. Paths are a root of directly connected computing devices in a computer network. It starts at the sender, it can go through many devices, and the path will end at the receiver. And routing refers to the process of finding the path from the sender to the receiver. It can include many different devices in the network, or it can just be direct. The bandwidth of a computer network refers to the max amount of data that can be sent in a fixed time. It's measured in bits per second. For example, in a computer network, let's say you can only send 10 bits per second. That's the bandwidth. You will not be able to send more than that. The internet is a computer network consisting of interconnected networks that use standardized and open communication protocols. Essentially, there's these rules that govern the internet, but generally it can keep growing and many devices can connect to it. Access to the internet depends on the ability of a computing device to connect to an internet-connected device. For example, routers will help you connect your device, like a computer, to the internet. And then you can go on the World Wide Web, you can go on YouTube, etc. A protocol refers to an agreed set of rules that specify the behavior of a system. And the internet will use open protocols, which allows users to easily add new devices. That's why it's so easy to connect many devices to the internet, regardless of how many you've connected. And you should note that the internet, when it was designed to be scalable. That means it can keep accessing new devices and it'll keep growing to meet demands. So information in the internet is passed through data streams. These data streams contain chunks of data encapsulated in packets. And packets will contain the data and the metadata. Packets can sometimes arrive, excuse me. Packets can arrive to the destination in order, out of order, or not at all. This will depend on the routing system and how the path is. Protocols can rearrange the packets in order so that it'll be received properly by the receiver. Here are some examples of protocols which are used: IP, TCP, and UDP. And furthermore, you all should know that the World Wide Web is a system of linked pages and programs. The World Wide Web uses the internet, and it also uses the program HTTP, which is why when you type something, let's say on Safari, it'll say HTTP at the start. Fault tolerance. So fault tolerance really just refers to a system that can support failures. The internet has been designed to be fault tolerant with abstractions for routing and transmitting data. Redundancy essentially means more components are connected to a system. So if some routes fail, then the data will go through other routes and reach the destination that way. That helps mitigate failure in case the other parts fail. And you can achieve redundancy by having many paths between two connected devices. This ensures that even if one path fails, the data can still reach the end through the other path. So fault-tolerant systems support failures, non-fault-tolerant systems will not support failures. And redundancy increases reliability of the internet and helps it to scale to more people and more devices. In sequential computing, operations are performed one at a time. This makes sense, right? You start at the top, you keep going down to the bottom, and you're using one computer. In parallel computing, let's say you have two computers, you'll start both the computers at the same time, and they'll work simultaneously, and they're broken up into smaller sequential operations, and it'll take as long as all of the sequential steps plus the longest of the parallel steps. And speed up refers to the time it takes to do tasks sequentially divided by the time it takes to do tasks in parallel. In distributed computing systems, many devices are used to run a program. An efficiency of a computing system can be used to compare time used to complete the algorithm. The same algorithm should be used to compare on different systems to accurately test how well the systems work, as different algorithms might lead to different times. So parallel computing consists of a parallel and a sequential portion as stated. You'll run as many things you can as in parallel, but at the end, you'll probably have one thing left to do in sequential. This is more efficient than normal sequential computing, as you do many of them at the same time. Distributed computing allows problems to be solved which cannot be solved by a single computer because of processing time or storage. You'll have many different computers readily available, and you can use all of them together to solve the problem. This will help, especially if data sizes are large. Efficiency of the parallel computing system is limited by the sequential portion. Therefore, at some point, parallel computing will not benefit efficiency anymore. So there is going to be one sequential portion. If you keep adding more parallel systems, at some point, eventually, it's not going to benefit efficiency much longer. So only add until you keep increasing efficiency. Now we're going to go over the final big idea. This topic will be the impact of computing as a whole. So computing, as most things in life do, have both beneficial and harmful effects. So people can create computing innovations, which may not be anticipated in advance. Advances in computing have increased creativity in other fields, like medicine, communications, and the arts. Computing helps benefit these other fields. However, programmers have to consider the effects of their innovations. Benefits can be beyond what the programmer could have initially intended, especially if the program is ran or shared with many users. The digital divide. The digital divide refers to internet access varying between socioeconomic, geographic, and demographic characteristics between countries. People in poor countries won't be able to access the internet easily, and they might not be able to. This is why we need to try raising issues of access and try improving equality and equity for all people in being able to access the internet. The digital divide is affected by actions of organizations and governments in different areas. So computing innovations can have biases built in, or it could reflect the programmer's inherent bias. The person who programs the code decides all the things, right? So if he has biases, he doesn't think stuff will happen a certain way, he can write that in the code. This is why it's important to have many people working on it to try and reduce bias. And programmers themselves should also purposely try to reduce bias in the algorithms. And biases can be embedded in all levels of software development. It doesn't matter how advanced or how minimized it is. This is why including diverse perspectives is so important. Crowdsourcing refers to obtaining input from large numbers of people by the internet and using the inputs of that people to change your program. You get more points of views, which can benefit an innovation, especially through the internet. It's easy. You don't have to invite anyone over, and they can just do it online from the comfort of their own house and give input on your invention. Crowdsourcing offers more models of collaboration, such as connecting businesses, or social causes with funding. Citizen science refers to scientific research done by a group of regular individuals who may not be scientists. Essentially, just think of it as normal citizens doing some research in the area. They can contribute relevant data to research using their own computing devices. They don't need all the fancy equipment. And even we can do our own citizen science projects. An example of this could be maybe examining the different kids in different playgrounds, seeing how old the kids are. There are also many legal and ethical concerns on regard of computing innovations. The material on a computer is considered intellectual property of the creator. But easy access means digitized information raises concerns on IP. For example, there's so many ways to pirate movies, TV shows, so many ways to get books online for free, even though you should be paying for it, right? This is where the ethical and legal concerns come in. IP should be safeguarded. IP refers to intellectual property, by the way. Using material created by someone else without permission or credit given is plagiarism and may have legal consequences. This is good as it will prevent people from using inventions that they can't unfairly. Continuing on with the legal and ethical concerns, the Creative Commons is a public copyright license that enables free distribution of an otherwise copyrighted work. Content creators give the permission to share and use and build on the work if they use a Creative Commons license. Other people are allowed to use it for free. Open source means programs are made freely available, and they may be redistributed or modified in the process. Open access means online research output free of restrictions of access. Anyone can access the online research. Open source means anyone can adjust it too. These abilities help improve digital access to information. All three of them, you should know this is pretty important. Creative Commons, open source, and open access, and know the differences between them. Also note that the use of materials computed by someone else should always be cited when using. Certain computing innovations can raise ethical concerns, such as I mentioned earlier, pirated ebooks online. Some people think it's ethical, some people do not. But if you're doing it illegally, then you probably shouldn't be doing it. And do note that as it might occur on the AP exam. Now I'm going to go to safe computing. PII refers to personally identifiable information. It's information about someone that will describe them and define them. Age, race, social security number, all of these define that. Technology allows the use and exploitation of info by and for individuals, groups, and institutions. As you all know, all these big ad companies like Instagram, they use ads and other things to get their money. So they look at your information to get ads or to give you ads. Search engines can use search history for targeted marketing. And personal information, like cookies, can create knowledge on an individual. And unfortunately, information placed online may be used in non-intended ways, so that's why it's difficult to delete the information you put online. So it's important to be careful what you post and what you do. Safe computing continued. Authentication helps protect devices from unauthorized access. Multi-factor authentication is an example. So the user, or one way is, you know how when you log into Gmail, many people have two-step verification? That's an example. You need to verify from one other verified account that you're logging onto this. Strong passwords are also an example. It's easy to remember, but difficult to guess. Something you would know, but something someone else would not know. That's why several websites emphasize having a strong password with uppercase and lowercase letters and symbols and numbers. Another example is multi-factor authentication, where a user, you'll know the answer to some basic question, but other people might not. For example, what's your mom's name? Or what's your first dog's name? Encryption refers to the process of encoding, uncoding data to prevent unauthorized access. And decryption is the process of decoding data. Encryption essentially hides the data, so people lurking won't be able to see what it is. Decryption is decoding the data. The person who actually needs the information can see what it is. Symmetric key encryption essentially means one key is used for both encryption and decryption. The same key is used. But public key encryption means a pair of keys are used. One for public, which is encryption, and one for private for decryption. Think of public key encryption like a mailbox. The mail person, he can open anyone's box. I mean, he cannot open anyone's box. He can just put the envelope in. Only you have the key to open the box and decrypt it. Certificate authorities issue certificates, which are digital, and that value the ownership of encryption keys used in communication models. Furthermore, on your computer should have virus and malware detection. This helps protect a computing system against an infection. But what are viruses and malware? Viruses refer to malicious programs that gain access to a computer in an unauthorized way. They run independently on a computer. Malware refers to software intended to damage a computing system. Both of these are pretty bad. You wouldn't want it on your computer, which is why it's important to be careful. Phishing refers to a technique where someone tries to trick a user by revealing personal info about themselves. And then they use that to access sensitive information such as bank accounts. You have to be careful who you're giving personal information to on the internet. Keylogging essentially uses a program to record every keystroke made on a computer, with the goal of gaining access to passwords and other confidential information. A keylogger can install something on your computer where you get access to everything you type in. And then they'll use what you type in as something you typed in is probably a password. They'll use that to guess passwords to confidential information, such as bank passwords. A rogue access point is something that intercepts data being sent over public networks, which is why it's important to be watchful of lurkers when you're sending important data over networks, as rogue access points may be present. On many sites, there are sort of malicious links. They can be disguised on web pages or even email messages. So be careful what you click on, as it might install malware. Downloads, you can also download malware unintentionally from the internet. So that was all for the topics. And yeah, that was also all for every topic we did. It's not too challenging. There's just some stuff you need to memorize and know the algorithms well. Those topics I just listed, they will help you on the MCQ portion of the exam. But there's also create task. Essentially, in class, your teacher is going to give you some time to code something up, and it has a huge list of requirements. And on the exam, there's going to be questions they'll ask you about your code that you will fill in after the MCQs. Some examples for a create task can include a Jeopardy game, maybe an adventure story, or even just a tic-tac-toe game. And you can use any programming language you want to create it. So there are some important definitions you should know for the create task. Sequencing refers to the idea that your computer program will run from top to bottom in that order. And note that sequencing can be broken when you call a procedure. Selection refers to Boolean statements which indicate which statements a program will execute. For example, if you have an if statement and it's true, then your program will go through that. Otherwise, it will not. Iteration refers to repeating code steps for a certain amount of time or until a condition is met. As I mentioned earlier in the video, there are two types you should know: for loops and while loops. For loops will run a certain number of times. While loops will run until a condition is met. And yeah, these three are pretty important. You should know this for the create task. And yeah. Thank you all for watching. If you have any questions, please let us know down in the comments. And shout out to SlidesGo for creating this infographic, which was free to use.